Maybe start. So I request all deeply to come forward for the so that we can see the blessings of Masha.
You can slow.
Move your hand. We can't hear you.
Still, your voice is not clear. Just check up.
I request Dr. Madam to provide sampling to Professor AICTE. Now I request Ramesh sir, Ramesh Unikrishnan ji, advisor to provide a sampling to Dr. Manoj Kumar. I request Dr. Raghav sir Das to provide a sampling to Mr. Sankalp Singh. I request Swami sir advisor to present sampling to Ms. Prabha Balakrishnan. I request Mamta Madam to provide sampling to Ms. Apurva Verma. Thanks. And Madam, once again, Mamta Madam to provide another sampling to our chairman, Sitharam sir. Welcome to all for this August present for this familiarization session for UG VLSI curriculum. Before going into further to this session, I would request Chairman AICTE Prof. Sitharam sir to do the welcome address for the members.
Namaskar. Very good morning to all of you. We here for this session on familiarizing the UG VLSI curriculum. So I think all of you know that UG curriculum was developed by a committee earlier. We had actually already released it, and but anyway, it is the first year UG program. It has just come to an end. We're getting into the second year. So in the meantime, Purva Verma was very concerned about the content of the course. So then they all came together with some international committee we made. And they have come with a lot of revisions, and maybe revisions, I should not say, maybe more options for the students. And because there are, this topic is very, very complex. A lot of different expertise is required. Where it is starting with semiconductor devices and fabrication, aspects would be involved. So experts have sat together. And I thought it's a good time to hear to them see what changes have been made, and we can familiarize this new curriculum, which will be uploaded in our AICTE website and also sent to all the institutions who are offering undergraduate VLSI. Friends, as you all know that mission semiconductor has been taken by the government of India, and already two studies have been already started coming up, one in Gujarat, one in Assam by Tata's. Micron is also starting. So there is a lot of interest in this, and I keep hearing two stories. One is, we don't require so many people as a experts in these areas, because today, these factories have become industry 5.0. Most of the work is done by the robots and the AI. Okay. The other story is still, to be a leader in this area, we need to develop. But at the same time, I would like to tell you today, engineering education in our nation, it is not just producing engineers for India. It's producing engineers for the whole world. So you name a company, I think we have engineers from India in every company in the world, not just in India. Okay. And today we are producing close to 1.4 million engineers every year. And that's going to increase also. Okay, because our gross enrollment ratio in higher education is so low now. We have opened it up, so it will going to increase. So luckily, we are the youngest nation in the world. The whole world is looking at our very talented English-speaking engineering graduates. Okay, so I think it's a greatest opportunity for us to enter into semiconductor. As you know, this industry is completely monopolized by one or two countries, particularly Taiwan and China. So I think it's a good opportunity there. So in this particular VLSI design and technology model curriculum, which has been carefully crafted by the international experts as well as some of our faculty in our institutions and industry experts in India, to provide a comprehensive education in VLSI encompassing a diverse range of subjects that are vital for their success in the ever-evolving discipline semiconductors. So this is semiconductor today in our life is pervasive. Along with this AI, artificial intelligence, the life has become much more complex. So in such a scenario, so we need to give them a hands-on experience, and so that students no need to again go back to an industry to get trained. See what is presently happening, most of the companies, they take our undergraduates, graduated from our universities, and then train them for a year. So now their expectation is that all training happens within the college time period. So all skilling will happen here. The skilled people will go out. I mean, it's very easier to said and done because we know a lot of practicality is there. That's where I like Sapuro Verma's idea that she's also having teachers training and competitions for the students to build their own products so that they build confidence in them to do something. So here, this all these concepts actually, whether it is in core courses, electives, or projects, have been actually looked at, and a new curriculum, I mean, or what is industry-ready curriculum is been prepared. So this industry-ready curriculum, where we require a lot of hand-holding of industries, because the students have to also get place their internship there. We need to work together. So AICTE internship portal also plays a major role. So we have a very huge internship. So I request some of the companies who are not there to be part of the internship portal, so that even in semiconductor area, we can give right, connect to the students to do their internship during their tech projects, because now the second year they're beginning, so they will have a good time. It's a good time actually to decide and where to really, because nowadays students started thinking about in third or fourth semester itself an internship. So maybe a shorter internship in the beginning and maybe a semester-long internship in the third or fourth year. So this curriculum, I feel, will because lot of thought processes has gone in, a lot of deliberations has happened, and it has been presented. It was also uploaded in the website, right, for public comments. Hopefully,
Yes.
you got some
Yes.
comments, and that is also taken care. And I would like to thank people who have put in a lot of time in reviewing this, the earlier developed curriculum for BTech UG in VLSI. That is specifically Professor James from Digital University. And I did meet him in Bangalore along with Ms. Verma. And we did look at this, and I offered some suggestions to him, and then I think he has taken care of that. And I could see the committee, the curriculum revision committee, I don't know how many of them are online today. I would like to place on record AICT's thanks to them. Alan Ascoli from TU Dresden, Garrett S. Rose from University of Tennessee, Bhaskar Chobe from Seigen University, Germany, Harish Bhaskaran, Oxford University, UK, Rajesh Zele from IIT Bombay, who was the one earlier also involved in the earlier course development, curriculum development, and Ronald Tetzelaar, Professor TU Dresden, and then also we have from Srilal from Scientist G of ISRO, and then Song Mo Kang from University of California, Santa Cruz, and Shahar Kavinsky, he is from Israel Institute of Technology, and Vishal Saxena from University of Delaware. So now you can clearly see these are all the academic people. There are industry people from Apurva Verma from Armendia, Munideepa Datta from Armendia, Sankalpa Singh, Synopsys, Satya Gupta from VLSI Society of India, Ashish Kumar, Prabha Bhattaram, Cadence, and anyway our own Dr. Agarwal and Dr. Dinesh Singh were also involved in developing this revised curriculum. And today we are all assembled here to familiarize that UG curriculum to all the stakeholders, particularly the teachers and the institutes who are offering this program. As you all know now, large number of institutes are offering the UG program. And I think good training is required. We also have to now come up with the laboratories for them. And so we are actually working with the most of the nano facilities in AC and also SCL, and as well as CDAC also has come with teacher training.
Yes.
So a lot of work has actually happened in this direction. I'm very happy to tell you. Yesterday, there was a workshop jointly with Gujarat Technical University with Micron. They also started a big workshop on faculty development program on semiconductors. Particularly, they were focusing on packaging. So I think these are the aspects I think Professor Alex James will explain to us what he has done and how he has done it. So with these few remarks, again, welcome all the experts from both industry and academia, and also the people who have joined online. So I wish this will be a very successful program, but I will tell you this, particularly the way AICTE has worked on capacity building in semiconductor has become a sort of a model for the entire industry or the entire world maybe.
Yes.
Because here a lot of deliberations happened, and many people whom I met, okay, were very biggies in the industry, appreciated the efforts what we have put in. Hopefully all the students who come out will be ready and trained to go for and make India a notable figure in the area of semiconductor. Thank you. Namaskar. Thank you.
Thank you so very much for your keynote address, sir. Now I would request Professor Alex James that if he can take us through various salient features of the curriculum and how is it a very industry aligned, industry ready, experiential learning with innovative pedagogies, leaving enough flexibility for the student and a student-centric curriculum. So over to you, Alex. Thank you so much.
Thank you, Dr. Mamta. And as rightly pointed out by the chairman, this has took a lot of deliberation, day and night of work across bringing in a variety of thought and converging that into something meaningful that can be taken up at colleges at various levels. So when we were, as a committee, when we were looking at it, we had people who are coming from places where the systems where the VLSI industry was very strong. And we had like people who had navigated from like an Indian education system to a much more established, like, for the semiconductor. So, and many of the ideas came from that viewpoint. How do we make the transition that industry would like to see? So then we went with an initial framework or idea, talked to the industry. Then the industry also had like a different view. So then we went back, and there were a few iterations on how we should go about the whole the training part of the curriculum. So one of the things that we looked at is where is the industry going and why we should care about some of the areas that we are talking about. If you look at by 2036, expected that this semiconductor market is going to be $1 trillion, and most of it is driven by applications. We see very good segments here, whether it's consumer electronics, computing storage, automotive, industrial electronics, wireless communication, and wired communication. All these areas are growing. And when we're talking about applications being growing, it's the whole connected, like from manufacturing sector to design to all the different aspects of VLSI that gets that demand also pushes in that direction. So how do we take into account all those things? Now, the two parts that we are actually saying in the degree title itself, one is the design and other is technology. So when we look at design, some of the areas that we have to look at is analog and mixed signal. The digital side and the FPGAs, EDA is one of the other aspects. System on chip and systems. So these days, like there is a lot of interest in chiplets and other things that are coming up. From a technology point of view, if you look at manufacturing, it can be again like split into multiple areas, including equipment development, the material sides of things, fabrication, packaging, assembly, and test. And if you've seen in the last 2-3 years, there have been a lot of interest across the world in having indigenization of these technologies. And how do we and put together the investment as is keeping on increasing. Like if you look at like what is happening in, for example, US, like the investment has been quite high, and they're still further investing. Like around TSMC alone is investing around $60 billion. And India again, like you can see, packaging and test and related things we are starting with, and we are going into packaging. Now, when we see that one, slightly pointed out, the jobs in that factories may not be a lot. A lot of automation has gone into. But if someone has to build indigenously equipment for those foundries, this is a different thing. You would need a variety of like engineering disciplines to actually come together to do that. So what it does is it promotes all the other areas that we are seeing here. A foundry is not just a foundry, jobs in the foundry, but it's also all the connected industries that get developed across it. So the reality of job reality, if you look at still like design is the largest in terms of numbers. Manufacturing, you can see relatively less, but still like large volume. And this is something very important to note that when we are developing our program, we are not just catering to the market in India. We are also catering to an international market. Because many of the graduates from here would be also finding jobs in all across the world. There is a huge lack of talent, not just here, but in Europe, in US, and across the world. There is a lack of talent in many of these areas. So that's why. So once we were giving like a talk in Berkeley, and then there was a discussion on the first question that was asked is, do you know what is IC? And people were saying like integrated circuits and all those things. And then the answer was Indians and Chinese, because most of the class was just Indians and Chinese. So this is the part of the story that you would see, that the talent is spread across, and the market that we are looking at is high skilled manpower has a job to get like anywhere around the world. And from the product side of things, you can see already many companies in India, and they are again not within India, they're spread across. So design space today, it's not just someone designing a circuit, but it's also a lot of systems engineering to other things that go into it. So someone who is able to understand packaging, someone who is able to understand various kind of like testing, verification, apart from the design, is also equally important for the industry. Memory is another area. It's a huge area, and in India today, like we have few activities from the design space, but manufacturing space is still quite early. But that's again another area to watch for, because the number and volume what may be required in memory is also going to increase. The technology as such, if you look at from, if you just think processing as an area, processing in, you have altogether another area coming up, processing in memory, which will again drive memory. So the idea of memory just being like storage to maybe also becoming more useful computing and other tasks is going to drive another level of like memory related like progress. And displays is another where in India we don't have a lot of activities in display, but this is again like Government of India has recognized this and is trying to push this direction as well. So both from the manufacturing sector as well as from providing the manpower who could understand the display and the design side as well as like testing side and things like this eventually would pick up. Currently, if you see, most of it is from China and Taiwan who are dominating this field. Now, foundry, it's a slightly more complex when it comes to skilling, because it's not just VLSI professionals that will be required in a foundry. So you would have, say, power system engineers to be needed. You would have chemical engineers to be needed. You would have process engineers to be needed. So the kind of foundry jobs that we are looking at, that's not the only thing we should think of. And when we think about manufacturing, people training people for manufacturing, so the intake to that would be much more large. Equipment manufacturing is another. A variety of companies have shown interest to set up like equipment manufacturing related to semiconductors in India, whether it's a small scale to large scale. And this is another area we would have to encourage people to work on, because a lot of the self-reliance in semiconductors and VLSI depends on that. When, if someone is setting a foundry today, most of those IPs and technologies are coming outside from India. So if eventually we have to be Atmanirbhar in this area, this is definitely an area that we need more and more people to come on. So from a curriculum point, what we were looking at is we have a lot of colleges in the country, and the facilities in the colleges vary. The nature of the students who are coming into these programs also vary. So we are not looking at like a uniform kind of environment. We can maybe have a minimum standard, but then the maximum could vary quite a bit at the intake level. Now, how do we cater to that? Unless and until the choice is given to the faculties and given to the students, there is no ownership in learning happening. So one of the things that we were looking at, how do we bring in a lot of ownership in teaching the program, in the learning process and things like this, so that a student would have a choice, the faculty would have a choice to use their skills and also pursue their interest. So flexibility in that teaching and learning process was looked upon very carefully. Along with this, how do we bring in like industry? Industry has over the years created a lot of learning resources. And partly the reason for them to do that was there was a gap. And to bridge that gap, they have been doing a lot of work. Now, this has always been that that's going in one direction, and the curriculum was going in another direction. How do we bring those elements into the curriculum? So that was put as part of the structure of the curriculum, made it like a formal, so that like all those content that has been generated, knowledge that has been generated, can be incorporated into the learning process. Then another part is many of the students may not be. If you look at the curriculum today, there is no research component. If you look at internationally, many good programs in the world, undergrad programs in the world, there is a lot of encouragement and credits given for pursuing research or pursuing internships very early on. So it's not we wait for fourth year or to really think about it. So in this structure, what we have done is we are assigning credits as early as in the third semester onwards, where people can start working on certain research problems, or they could actually take up mini internships and things like that. Another idea that we were looking at, how do we bring in more of industrial practical experience in the curriculum? Students these days, from a theory point of view, you would see as teachers, you would have faced this, you would be delivering a course, they will be somewhere else. The attendance is there, but the mental presence is not there. And a large part of it is coming because the attention spans are very less, and the engagement to theory is usually very, very difficult. So that's why, how do we bring in project component to make them more engaged? How do we bring in some kind of practical problem-based learning into the program? Was thought about throughout the sense of philosophy. So discussing across board with committees, several people, many of them were not listed there, but the consultation was much broader, and we identified 7 areas where we need to focus on within the program. And the idea here is, so we have 7 of these focus areas. So foundations to these programs are given in the first 2 years.
Can you enlarge it a little bit, because too many people have joined in? There are more than 200 people who joined in. So I think it's may not be that visible. 231 people are there. So can we zoom it out? I think you can, right? Yes, yes, increase, because so that people can see it easily.
Yeah.
Even if need be a little more, because
Even further increase it maybe a little bit more. I'm not able to do it.
yes,
Yeah, okay. So the first the first focus area is semiconductor devices. So we are looking at device modeling, the whole physics of it, and if someone is interested in going to a device direction, that would be the track. Then we have analog, mixed signal, and RF. It's mostly the design side of things. If you focus area 2 and 3, one focusing on analog, mixed signal, and another on digital. Then EDA is another focus area. So there are a lot of companies, and the whole EDA area is changing as well with AI and many other tools coming up. So that's another area that we are looking at. Display technologies is another area where India is lacking talent, and across the world also. Like if you look at it's a multidisciplinary area, many different aspects come into it. So that's a complete gap that we are filling in. Packaging is another track. As you are aware, like many of the packaging and test facilities are coming up. So this will cater towards that. And manufacturing. The manufacturing side, we try to broadly cover areas like clean room to the instrumentation to how a factory related things are set up, and all those things are covered in that. Now, the way the overall curriculum is structured, so there are core courses, there are program electives and open electives, like in most of the curriculum we have. Like in addition, we have projects and internships and a mandatory boundary visit. So everyone who is taking this program, what we are insisting is they need to at least visit one of the clean rooms and get a real sense of how the manufacturing and things like that are happening. So seeing helps rather than just assume that. From a structure point of view, you can see how we are. The first year, more or less, we kept the same because already the program has started and we want to test that. But then the subsequent common core is rather more like the foundations that is required across the curriculum. So if you want to be called as a VLSI engineer, then these are the very basic things. Then the program core, what it does is it delves into giving a flavor or foundation to all of these 7 specializations. So everyone who enters the program, they get a flavor of all the specializations, and then they can go into taking a major or a minor or a combination of these. Because at the UG level, if you flexibility in actually learning, some people want to just go for a general program. So they can go and take like every specialization 1 or 2 subject, or some people would want to focus purely on devices. Then they can focus purely on devices, get a major in that. And in some cases, they want to do a major and a minor, take one whole track and take few in another tracks. So all those aspects of technology, this is covered. Then we have the bottom part is minimize a little. Yeah. So there, if you see, we have every semester starting from 3rd semester onwards, you have a group project or a research project. So these group projects, essentially what it does is it sets out a problem, and this problem you can further work on for another 2-3 years, and you can build the complexity as you go along. So this can be research driven or it can be an industry problem driven. This is one part where you can actually bring in industry mentors as well, and get a joint supervision with the industry mentors. So many of the problems, if there is sufficient faculty in your institution who can guide that, well and good. If there are like lack of faculty, you could always get someone from outside to come into that supervision, and that way you can bring in like multiple expertise come into the program. And these specialization electives that you see here, they are essentially, it can be driven by industry as well. So industry has several programs already created. So you can get the industry courses to be plugged into any of these specializations. And I think some of the industry members would be explaining the kind of courses they have created. So all these courses are up to the offering to go into all these specializations. And the final year, we have largely the project. So last semester is completely kept for the project. So there is no additional courses or anything like that. So if the students want to go for a full-time internship in industry, that is completely allowed within this program structure. So there is no need for them to come back to the institution to take an additional course and things like this. Many programs today have that, and that becomes a challenge because they have to take those 3 courses or 4 courses and things like this. So that is completely removed, and it's purely focused on the project, which helps. So the focus of all those specialization electives is to make people industry ready, bring in industry design courses. Now, tools and technologies, like, we are not attaching to one particular tool, which means like whatever tools and facilities that you have, you can basically use that and leverage on that. And in addition, you can also get support for many other tools and technologies which are out there through those specializations. Maybe the industry can come in and help you take up those and get training in that to further grow the institution's capability. Again, what it also does is it gives a lot of freedom for the institution and the students to decide, like, not every institution would have all the resources for every other specialization. So how do we make it work? So that's where, like, many of these courses, the MOOC courses and everything will come into picture. The ones that are already there, the SWAYAM courses, the ones that are there in industry, all those can actually bring in to help and fill that void. And the restrictions that many institutions have can be completely, or at least like to a large extent, reduced. So overall, keep structure like this first 2 years, first year like more or less same. Then you can see here like these research projects or microcredit electives like can go from 3rd semester onwards. So if there are industry credits, if you want to introduce early on in the program, that is also allowed. So from 3rd semester onwards, you can actually have the industry electives coming in. And that is which elective to select, and it was completely up to the institution and the students to decide. From a credit point of view, there is a sufficient room that is kept in for whether doing a project or taking a few elective based on how the institution see it to be very effective to the students' learning. So the first, you can see 3rd and 4th semester, it's very much the foundation. Some of the courses that we introduce, like, this is hardware systems engineering. Systems engineering thinking is becoming more and more important. It's traditionally not covered in the VLSI curriculum. But given the complexity of the chip design, what is happening, that a specific course has been created for this as a common thing. So going to the 5th semester, 4th and 5th semesters, 5th semester, it's like giving flavor to all the various specializations. Certain courses like SOC Design 1, Design and Verification, then we have SOC Design 2, where the students are given the complete flow from taking it from the idea to design to fabrication. The entire flow is covered in 2 courses, so that every student who get into the VLSI program knows how do you take an idea to design to take over. So that is kind of like one core course that is. Then certain other courses are like displays, like to support displays, optoelectronics and optics is included. And then we have several electives which go in, all these electives are going towards the specialization. So what we are having is these specialization slots, along with every semester you having a slot for industry specializations to come in as well. So which basically means like there is more than like around 60 credits which are focused towards that study. And final year, like purely on the final semester we will learn. That's the overall structure and the idea of the. Thank you.
Maybe a brief introduction of all the experts. Yeah, before you take the questions, very briefly.
Thank you so very much.
They know who are there. No?
Yes, Professor James, for giving us a very comprehensive overview of the VLSI curriculum that we have prepared for our UG graduates. And then this is the first time, all our committees for curriculum design have about 40% of experts from industry. But this is the first time that you name an industry and it was onboarded, from Cadence to Synopsys to ST Microelectronics to ARM India, Applied Material, VLSI Society of India. And as enthusiastic we were, as meticulous we were, equally enthusiastic, if not more, was the industry. So we, on behalf of Chairman and our entire fraternity, we do keep the appreciation for the industry, because we definitely need a very strong academia industry collaboration to make sure that all our courses and our students are employable, they have full experiential learning. So thank you so very much. And as our Honorable Chairman has suggested, and I think I apologize that we did not do it initially. So if we can also have a brief introduction of all our friends and all our distinguished experts from the industry, starting from Apurva.
Hello everyone, I'm Apurva Verma and I take care of ARM Education for India. I work with ARM.
Thank you, Dr. Manoj.
Morning everyone, I'm Manoj Kumar from ST Microelectronics. I take care of particularly the global innovation office activity based in India, and of course one of my responsibilities also to interact with the universities.
Issues coming from
Prabhaji.
Hello everyone. My name is Prabha Bhattara. So I'm from Cadence Design Systems. So I was a design engineer and a verification engineer. Part of the global technical education. So that's how I came into this. Very glad to see you. What more exciting.
Sankalp Singh ji.
Morning everyone, I'm Sitharam. I take care of the university program called as SARA, which is Synopsys Academic and Research Alliance for India. And we are a very small team. We're just 12-member team all across the globe, covering each region. So I am heading the India.
Thank you so much. And all the faculty members who are either present here physically or are available, connected to us in an online mode, I would request you to kindly post your questions in the chat so that the experts can take the questions. Meanwhile, we will actually also have sessions from all the industries informing the academia what are the resources that are available at their disposal, either in a software or a hardware form, and how can the students of all the colleges, all our institutions, our technical universities can take advantage of those resources to make students future ready, to make students having absolutely good experiential learning, and how can they be seamlessly integrated after their academic achievements into the industry. So we will first have it with Apurva from ARM India. So you can, ma'am, give us a brief about various resources that are at disposal, and ARM India wishes to extend those facilities for all our students and faculty members, research scholars. Thank you. Over to you, Apurva.
Thank you, Dr. Mamta. I was just wondering if we could do a couple of questions for Alex, 2-3 of them, and then we'll be all around post the session. You can always come and meet us.
Right.
If anyone has questions here, we could maybe take up, or I can go ahead and do my presentation.
So physical people can ask question here, and Manali, please check if we have questions in the chat box and we can take up the questions. All faculty members who are associated and connected through the medium, online medium, kindly keep on posting your questions in the chat box. And all these PPTs from Alex as well as from all our faculty colleagues will be circulated among all the institutions. Thank you.
There is one question on what are the open source tools available to VLSI students. So I just want to say that like the IEEE Circuits and Systems Society and Solid State Society had like a couple of programs. Like one of the thing, and these are all open. What we could do is we could link that to AICTE and put it. They are all open. Entire like training materials to all those things are there. Several courses are also there which can be used, and these tools are all free, and they're supported with Skywater Foundry. So that way, like if some of students want to fabricate the designs like that, that could be also possible.
You can think of minor specializations because there are various minors because in other fields also. So you can elaborate about minor.
Yeah. So what we have put in is like we have micro credits option as well, where if students suppose they are doing like civil engineering, they want to know a specific, say some circuit related, they can go and take like those circuits and attain like a minor. So the minor definition would be like we put like something around 9 credits. So that way, like 3 or 4 courses they can take, and that way they get that very specialized skill in that area, which may be complementary depending on what they.
I have one suggestion, based on the model curriculum you prepare. So there are material already in SWAYAM and SWAYAM Plus. You should give a link to that in the curriculum itself, so that they should be able to, because everybody will not again search. So many emails are going when they're complaining. AICTE, so many emails, so they're not able to track. Better is in the curriculum itself at the end. You can give the resource materials what are available in general.
Right. We did it for industry. I think we'll add this.
We added for NPTEL, but we have to add for SWAYAM all the.
NPTEL is same as SWAYAM.
Oh, we added.
SWAYAM is a broader one. Okay, now it has become SWAYAM Plus. It means even your course material also can get micro credits. Yes. Some of you should also try to put in there. This SWAYAM Plus was only launched a month back. Okay.
We will do the mapping and then.
Yeah, kindly. Yesterday started already. It's going on. Today is going on. Micron and GTU are together launched a 3-day workshop.
And I don't know, ma'am, you have done it or no, but AICTE last year had an exclusive FPP with SCL Mohali, that is Semiconductors Lab Mohali, and exclusively for semiconductor domain. And it was a very, very experiential. And we have also had about 50 Atal FPPs on.
And also CDAC is also going to train 1 lakh in semiconductor only. They have a big group in Pune. They're also taken up. We have signed an MOU. They're going to train 1 lakh on the semiconductors. There.
Kindly introduce yourself, ma'am.
I'm professor from college, now called as
In Hubli.
chairman.
Okay.
We have inaugurated
Good. A lot of facilities are now coming in. So nothing to worry about it. That's why I said we have. What you have to do is put all these information, collate and share with all the 300 colleges. See, the problem will only come in rural part of India. Okay, the colleges who have just taken this program for adding money to their societies, only it will be in problem. Rest of the colleges are already prepared actually.
Kindly introduce and you can put on your mic, ma'am, please.
Good morning, sir. Sir, this is Atisha from VLSI College of Engineering. Sir, do we recommend set up any laboratories for this? In that case, can we just?
No, it has to be. See, please understand, you don't need to ask a question. You are a professor, isn't it?
Yes, sir.
See, this is a mandatory. See, when you say I am running this program, it's mandatory to develop laboratories and faculty.
Sir, then we have a lab on micro application. So, can you elaborate about that micro prediction systems?
So Alex, can you also brief her if they can collaborate with any nearby labs? So madam, you are from Tamil Nadu. Which part of Tamil Nadu? Because you can tell the place.
Indigal.
Okay, Dindigal. So what will be the closest? Probably Bangalore IISc will have a lab, and you can collaborate with them, and they allow sharing of their resources for.
You know why Shastra is there? You just go to Shastra. They will tell you they're running this program for a very long time.
At Shastra University.
In Tanjavur. In Tanjavur, okay, we'll connect you to the Vice Chancellor and he will help you also. Okay.
So we'll connect. I shall share the number, and I'll also shall have a word. Yes. Okay.
So if
So microcredit, the idea is that you have existing industry-led courses. So those can be plugged into as microcredits that students can take. Same with but the idea of microcredits is complementary to the subjects they are taking and
not propagated our idea of microcredits. It very clearly shows. You see, madam, 40% of your courses, students can take 40% of your courses in any program. You can take courses from SWAYAM and SWAYAM Plus, as well as NEET, National Education Alliance for Technology. There are a lot of courses actually. These are all 1 credit, 2 credit courses. Okay. Only thing is, earlier days, evaluation was a difficult thing. Now, who is going to give a mark to that? Now there is a mechanism now. Even yourself can do it. For example, if there are 60 students taking a course on SWAYAM or NPTEL, you can conduct examination at the end of the course. That means college can conduct the examination. So one person said, I don't have expertise. Then, you have to contact a person who has an expertise, prepare a paper and get it verified. That is why the FDPs are helping you. Faculty development programs will actually train you to do that. Okay. So that way you can actually deliver that course. So that is why without looking at what they should do, many colleges have taken VLSI. So we need to now train them.
On the job.
Nothing to do with just VLSI. Let me tell you, it is all in every program. So it is a new thing. They will learn. We have to give them some time also. Maybe luckily in UG program we have 2 years. Just 2 years somehow they will manage. 3rd year say real core courses and start. Yes.
We'll
Okay.
try and do in the next couple
So
of months.
anyway, I have to leave. So I wish the program great success. All the best. So please continue.
So this is second year. VLSI. We'll be stepping into third and fifth semester. Further down the year, they will come for placements. As it is, VLSI is a niche area. Placements are very less.
It is second year or first year completed and getting into second year?
Second year completed, they'll go into third year.
Oh, already. Okay. 2 years ago.
Yes, the first batch will go to third and fifth semester.
No, I think you're wrong. Because after I joined only, I started this program.
Last February, you'll launch.
VLSI is fifth semester. We are running fourth semester.
No, maybe your college. You may be earlier.
College.
See, because you have developed, you are only one college. My 300 colleges are only into 3rd semester now. Which we are,
February launch.
you might have started early because your vice chancellor, I know him.
So anyone from industry?
No, it should be 3rd
like
semester.
answer to that question, what madam has asked about the placement. So somebody, all of you are here from this industry. Prabhati, would you like to say something about it? So you have a request.
placement sheets. So parents does go to list of universities. Reach out to the students and workshops as well as.
So can I come and meet you in the afternoon around?
Yeah, I'm here. I'm here. Okay. Thank you.
It's not, they are only into not like a general VC where they can go into communication or internet or anything. So companies will be that field. How do we get it to the employment? So many.
I think the max AICT can do is give you a listing of the organizations which are looking for these niche skills. And then you'll have to do your own bit of, reaching out through your training and placement, and then
In the sense, like taking one maximum four.
I think the larger problem is that the skill level that is needed to the industry, the expectation is slightly different. So most of the students end up like getting a lot of theory level things, but what industry currently uses, say for example, how many students would be familiar with a say 5 nanometer technology, or devices, are they familiar with like gate all around transistors and things like this? You would see not many. And even some of the topics, like for example, I haven't seen many students getting trained on signal integrity or any of these. So when it comes to that, there is a gap. And so the industry have to usually lower their expectations, and then they try to train them. But how many people can they train? So it's all coming down to that.
In fact, I have a suggestion, ma'am. Like, Shastra University has done it. If suppose your students have come to a state where they actually require some of the fabrication labs, you have either you need to really tie up with HCL or IISc Bangalore where they actually have it and can explore the facility. That is possible, from Hubli. If suppose that is not possible, you can also send your students for a semester exchange program to Taiwan, and Shastra is already doing it. And they will be more than happy to do it, because actually in India, we may not have manufacturing facilities, labs, but worldwide, especially in Taiwan, they are available. And if they are hands-on, they will be picked up like hotcake. So, when you're thinking about a placement, you need not think about the placement only with respect to India. So, it's a visionary approach. It's a visionary approach. So our students, even if they get deployed and employed in different parts of the world, and they come back as an absolutely, trained, skilled manpower in VLSI, as and when our ecosystem is fully prepared, that will be the most welcoming change. So, you need to make them progressive in their thought process, that, okay, maybe as on date, I do not have facility for it, but, we are in the process of creating these facilities. So you must make sure that they actually have hands-on training. I can help you out, either with Micron or with Applied Materials, or maybe with ARM India or IISc Bangalore or SCL Mohali. Please reach out to them, pay a visit, have MOU. And, I will also connect you with the Shastra VC. You can take the mobile number. How have they done this 6 months exclusive internship for those students who wants hands-on training in the real scenario fabrication manufacturing lab?
We have that. Yes.
So I think, so we will talk this after this is over. So now I will request Apurva ji to give her presentation. Thank you.
Can we take it off?
See,
We're all there.
see, all of us are physically present here. So, we are here for about an hour we have for lunch. So during that hour, we can take a lot of our questions forward and we can discuss, because otherwise this program will not be over till. Thank you.
So I did introduce myself. I'm Apurva and I take care of ARM education. I hope I was audible.
Maybe, but if you make it a little louder, it will.
Louder. Closer to the mic, okay. Yeah, hello everyone. I introduced myself, but to kind of repeat I'm Apurva and I take care of ARM education. And those of you who are not familiar with the ARM, to give you a kind of a view, can I have a slide change, please?
Quickly change the slide, Manali. Next one.
The third one. Third one. The fourth one, yes. So what we do is we develop the IP, which is kind of licensed to the semiconductor ecosystem. The semiconductor ecosystem, depending on the product they're making, they're adding the features and then they tape out the chip. So you will see that we don't manufacture anything. We are an IP provider, and the revenue of ARM is dependent on the licensing of the IP and the royalty on the chip. So what I think there's a bit of slide mismatch between what I'm talking and what is being displayed. So I think you can ignore that. I'll continue speaking. Not changing. Yes, you're right.
So do you want to sit there and do it?
Yeah, I could do that.
Rakesh, from the other side, you can do it. Apurva, should we take the next one and then would you like to come back? Okay.
Okay, so this, sorry for the slight disturbance. So I've explained to you about the model. It's not on? I've explained the model of, the business which ARM runs. If you look at the presence of ARM technology globally and the number of, can you see that? Not this one? It's on. Showing very light. But can you all hear me? Okay. Coming back, so our semiconductor partners have shipped close to 290 billion devices based on ARM technology, and that's the global presence we have. So ARM always has been an enabler of technology, and that's how you see that ARM IP is licensed, and there are like large number of semiconductor organizations which take, license ARM and then, build their products and devices. So this is where we come from. Can I? Coming to the ARM education initiative, we have the same thought process where we want to kind of enable faculty across the globe to be able to teach subjects from the foundation to the I would say advanced level in a way that it not only helps students but also is preparing them for the future technologies which are coming in, and that you will understand because you would have in your engineering started with microcontroller embedded. You never heard about IoT, AI, ML, and now there is this whole change which is happening, and there is also need for in-depth knowledge. And that is something, which we want to help faculty do. And that's where we come in. If you look at, the program, we have different initiatives under ARM education. One is the university program. Most of you must be familiar with the university program by taking resources or having interacted with us. The other one is the research enablement program. This is much more newer, I would say, which is 3 to 4 years old and maybe 3 years old in India. Here we provide the ARM IPs so that if there are any research activities which you would want to do in the semiconductor domain and you need ARM IPs, this is what will help you with that. Coming to the program itself, I'm not going to talk about research. I'm not going to talk about the school program. I'm just going to focus on the resources you are having as part of the university program. You will see here that we have teaching material, software, online courses, books, and tools available. Before I start, these are all available free of cost. There is no charge for the institute in any way. And over the last few years, with support from AICTE and individual institutions which have been reaching out, we have been providing these resources. Coming to the teaching material, Alex did take you through the curricula. Most of the content is available here. You don't have to recreate. These are generic courses. That's why I'm saying don't have to recreate. You can take it, modify, edit, teach it the way you like to teach, because we don't want you to stick to what is given. It's up to you to kind of rework on it and then take it to the classroom. If someone is interested taking it to the classroom as is, please free to do that. So this material you're seeing to the far end, these are like 40 to 60 hour content, both theory as well as lab. What we have done is, with theory, we've gone from the foundation and then slowly moved on to the advanced level. That's why you will see embedded system 3 courses, SOC 2 courses, and so on. Lab manuals are detailed step-by-step instructions with applications and case studies being available. That will help you understand, if you're not familiar with some of the newer developer boards like STs. It'll kind of familiarize you with that and also help you build your future material. Case studies are also available, makes it easy to understand from the application perspective. My colleagues from Cadence Synopsys, ST will take you through their resources. You'll see how this complements what they have with them. Coming to the software, if you're not aware, most of you, if you've taught microcontroller course, you would have used Kyle. We have something called the ARM Development Studio, which is a mix of a lot of software tools and debuggers and all of it. This is available. Professional tools are available at no cost. The process is, I'll explain it to you quickly post this. Anyone, any institute which is teaching these subjects and needs access, we will provide it to them. It'll be there for a year. You'll have to come back and renew. When you come back and renew, again, there is no cost. It's just that we want you to use the tools and not leave it unattended, because these are really expensive tools and we need you to utilize it effectively. So take as much as you want, but please use it. That's a request from my side. We have online courses both on edX as well as Vital Source. These are typically video lectures, video demonstration of labs to make your life easy if you don't like reading, from the presentation and lab manuals. So this is available. One disclaimer here, content on edX is available free of cost, but if you're looking at certification, it is paid. We don't want you to go with certification if you don't want to, but the content is available for you to go through. And there's no difference in the content you get when you're going for a certification or would like to view generally. Then we have books to complement your learning teaching process. A lot of books available. The e-versions are available. You can download, put it on your system and use it whenever you would want. Pass it on to your students so that they can learn from there. Specifically for a computer architecture course, we have the graphical simulator that is available on GitHub. You can go and download and use it for teaching the course. Here, I wouldn't take a lot of time, but there is a process for each of the material. We will share it with you post the meeting from Dr. Mamta's team. GitHub has the resources. You just have to go and download it. The process is explained in the presentation. For the software tools, we would request you to fill up a form, tell us how many licenses you require. A colleague from my team will reach out and ask you a couple of questions to see that you are actually wanting for projects, lab work, and all the other things, and we will pass on the licenses you require. Courses on edX online platform, again, this process is simple. We'll give you a voucher code, and then you can take the access for the courses as well as the textbooks. Simulator is available on GitHub again. You can go and download it there. So what we'll do is we'll share the links and then you can access. If you have issues, find it difficult, not able to figure out, I put in email IDs of both myself and my comfortable, and we're all there to help you out, and see that, you get comfortable with the usage of resources. There will be trainings happening in the future the schedule will come later. But for now, in terms of the resources we have, this is where it is. I can take 2-3 questions and then maybe pass it on to my other colleagues to present. Any questions for me?
I think the only question will be that we will be sharing further slides along. And all my industry partners, I request to have one email ID where all the faculty members who are present here, because once they will start using your tools, that is the time they would like to reach out to you. We are having this problem, or what is your schedule of training? So please, all of you, share one email ID which should be responsive, and at least within whatever you say, 3 to 4 working days or 3 to 4 business days. Our faculty members, our research scholars, they should all be responded to, and all the people present here, all the faculty members can send me the email ID. So we will be sharing, because generally we share every presentation with either your vice chancellor or your registrar. So what happens, I am not too sure whether it actually reaches down and percolates down to the real person who is concerned about it. But since you are present, I want to make a request that please tell your vice chancellor and your registrar that we would be receiving such a material, kindly forward it to us. Being an internal one, you can always make that request. So is there any question for Apurva? Otherwise, we can move on to Manojji from ST Microelectronics to make a presentation. So yeah, please speak, please. Yeah. Ma'am, please introduce yourself and ask the question. Yeah. So you can put on and you can be louder, because that can be a question of anyone. We will also be talking. You want to go to the washroom and come back? So thank you so much. Over to you, Manojji from ST Microelectronics. So please let us know as what are various resources that ST Microelectronics would like to make available to all our students, all our faculty members, and all our research scholars? Thank you.
I hope people can hear me. Is it work?
Yes, yes.
Should I unmute my this thing also, or it is no? I'm thinking from the remote person. Able to hear? I share my screen. So thank you, thank you AICTE, thank you Apurva. I was wondering that when it is a VLSI specific, how do I present it? What I think Apurva made it simple that it is VLSI, but also beyond VLSI, there are, let's say, products people need. So while listening to Apurva and before that Professor Alex, I did introduce some slide here in order to make it more relevant, so they could be a little jerk in response compared to what it was when I started from home. All right. So ST is about 50,000 employees, and it is important to mention here that ST is one of the IDMs, and IDMs are integrated device manufacturer. That means we design as well as we have our own fabs, 7 front end and 7 back end. I think this was taught what is front end, what is back end. So we are a unique IDM company in the world. In terms of what is our focus is on smart mobility, power and energy, cloud connectivity, and autonomous things. I would focus on the rightmost one because that is more relevant with respect to my remaining part of the presentation. Before moving forward, just to tell that we started in India in 1987, and today we are about 1,200 employees and engineers, and most of them located in Greater Noida near here, and about 100 in Bangalore as well. I pulled in this slide because it's important also to set the context. And this slide is not from us, because it's from the right side, it is from India Electronic Semiconductor Association, but it is pretty much about the silicon semiconductor ecosystem. You would know that in India, we have different figures. Someone says that we are consuming 100 billion worth of electronics already. Someone says 80 billion, someone says 150, and so on. And then there are projections that we would be having, let's say, more than $500 billion of electronics consumed within the country. When you talk of the consumption, you are really talking of the last part. And I would just highlight a few other parts. It's very relevant for the semiconductor professionals to understand what is happening on the top is basically what India has been great already. That is design on the fabless. We are great at IP development, EDA tools, silicon validation and design layout. Until this, all of that is happening is the design part, and you don't need a fab. It's a fabless job, and that's where India has excelled. It is said that India is probably having 20 to 25% of the global design based in India and contributing to any company in the world. Then comes the front end manufacturing, and it was told in the beginning that there are now 2 more which are coming besides seeing that has now. There is also back end, and there are 3 plants that have been announced. It is called differently, call it back end packaging or OSAT, which is outsourced assembly and test. The last point is what we consume is really this. I mean, what is done in the front end, back end for the factories remains in the factories. What is the last part, which is the product assembly or the electronic system design, is something that we touch. All the mobile phones, I mean, here you headsets, cars, everything that you come over here is this. So my presentation, and that's why I built this context here, that while of course there is front and back end, which is very, very important, and we are as a country, I want to also inform, what I said before was that we are consuming probably $100 billion worth of what is the last one. In India, we are purchasing only less than $5 billion. Yet we are consuming $95 billion. This is a product design whether happening in India or elsewhere. So it's an important parameter for us to understand also when we are talking of employment, when we are talking of the factories, when we are talking of the carriers. Basically, Apple, for example, if I name one for me, may not be designing its own chips. Certainly now it's starting to design, but what they are starting to do is really selling the product. And this is a very, very important aspect. With that, I will go to my presentation at SST, and focus or request from Apurva was to speak about IoT and AI in particular as to what do we all know. So when you talk of the IoT device, what you're talking of a processor, or let's say something that can compute, security for it, sensors and actuators. You need to connect to the internet, to the cloud, and so on, or maybe just to your mobile. You need some kind of connectivity, and if it is IoT device, it can also be wall powered. If it is wall powered, it requires to be more power efficient. So all of those are the key components of IoT system. How you can build one? Of course, you always can move the device with your own board, and then of course see if the board is working, etc., etc. Then you bring further components. What can be an alternate approach? Alternate approach can be that before you really decide, okay, watch is my final system for example. Before you make a final watch, that means you need to have the compressed hardware and compressed software and so on. So do you start with the watch directly? It can't happen. You have to start with the boards which you can use for the prototyping. And as ST, we have this prototyping board, which looks like this. I brought one just for that I mean, not to suspect that anyone doesn't know it, but this is, for example, a computing platform that is on STM32. STM32 happens to be flagship from us. Now, with this, we can really teach and understand every kind of programming. And good point is that when we talk of STM32, we are talking about a ARM-based product coming from ST. We licensed from them, but today we are having more than 1,000 unique parts. And even if you have one single board, the way you teach or learn to the students, the programming context and everything environment would remain same across that. Then the variation could change. For a watch, you need low power, low footprint, and so on. For another big display system, maybe you need much bigger, and so on. But the consumption, the construction would remain same. What we have done is that, of course, if you have this kind of board and you need to add connectivity, you can have an add-on. Once you have this add-on board, you can really start programming software and so on. What is the beauty? Even when you go from these multiple boards to the form factor board, which can be what? Compressed software that you have validated remains the same. That's why when a startup is going with the POC itself, it is able to see whether to come up. That's the whole thing. Then, of course, there are form factor boards. That means you can have multiple such boards, but you can have a single board which is very and so on. So we I have sensors, I have connectivity, I have computing, and it goes to the cloud. But for the cloud, there can be some software somewhere which is downloaded.
Keep it enhances the model.
I want to say that when you use our platforms, we have done so much of development.
No, it's okay.
It just enhances the model.
Yeah, so much of let's say investment has been done that all of this is available from ST website and for free. And when we say for free, even without our knowledge, that means you can download without asking us, without telling us. So this is one point, and this goes into the education part as well. Let's look at the other evaluation boards. Now, from left to right, there is a, if you want complexity, that is increasing. So we have the Nucleo boards that I showed. It's like a single microcontroller if you want, or a microprocessor. Discovery kit would mean that you integrate large number of functions into one. This is one of the discovery kits. For example, it's a IoT board. That means you simply, with this single board, you are able to understand programming, you are able to teach programming, you are able to go to the cloud, and you are able to control even the home appliances and so on. Then evaluation boards are, let's say, much larger platform where maybe the R&D teams are using and so on. And then these are, let's say, specific expansion boards. Let's come to the resources now. These platforms, if you go to wwst.com and then there is this educational platforms, you would see that there are IoT, low-level firmware, robotic automation, TinyML, etc., motor control. These are the courses which are available, and each of the courses you would see there are resources. There is a suggested board, there is a MOOC online, and there is corresponding software that you can really download using the tool, using the tools that are suggested, and you can start working from let's say day one. And these are, and this is not to say that these are also, Apurva was mentioning EDX before, so this is together with them. Okay, so all right. Then, of course, there is a large number of resources. There is a community. I talk of STM32 mainly because this is with ARM, but also this is one of the microcontroller or microprocessor from us based on ARM. There is a wiki for this. There is education that I already showed. Then there is a developer zone. So you can, let's say, connect, you can interact with the developers around the world, not only India. Now, there is a question that if, for example, you decide to, let's say, create a certain kind of lab, so what kind of resources could be available? Imagine that you somehow decide that, okay, this is the kind of board that is useful for your design or your lab, you can, let's say, do it with consulting us or even without consulting us. But if you decide on a certain part, all you need to do is you simply search the internet. So you don't even need to go to wwst.com, that will anyway appear. So when you search the relevant board, you reach wwst.com. So one of the options is on the right side. That means there would be options that you can buy from distributor 1, distributor 2, distributor 3, whatever you want. This is one option. However, if you need to have, let's say, some more consultation and some, because when you import a board, there can be also custom duty involved and so on, and there could be some issues with respect to the declaration that you may be required to make when there are, for example, particularly RF components involved. So Bluetooth, Wi-Fi, everything is wireless, and sometimes there can be issues for the first timers. If that is the case, you can contact a person from ST whose name is Sridhar, and there is a mail ID given. And of course, we have a distributor, and this distributor, instead of you connecting directly, I would recommend that you can connect Sridhar, and then he can, let's say, line up. And this distributor takes care of taking your payment even in the Indian rupees, if that is your, let's say, desire.
Actually, you can just read out Sridhar's email ID.
Yeah.
But, you know, in case somebody is not able to see it pretty well.
Thank you, ma'am. So Sridhar Athiraj is our India contact based in Bangalore. His mail ID is sridharaj@st.com. As you can read it on the screen as well. Okay. Then, of course, coming to the MOOCs. So you can have the basic level MOOCs, STM32 tools, various lines. When I say various lines, earlier I mentioned that we have about 1,000 parts for the same. And depending on if you are taking of, let's say, low power, low performance, high power, high performance graphics, touch and motor control, and so on, you can go. And there are, let's say, multiple, let's say, MOOC courses that are available. As I said before, you don't need to register, you don't need to tell us, you don't need to ask us. These are, let's say, available for you without asking. I want to also highlight, because now we are in India, what I showed until now was anyway the global offering. I want also to highlight that we also can help with some discussion that we could also have some on-site FDPs at our own campus in Greater Noida. By the way, we had 2 already in 2024 for so far. One was in embedded/IoT and other was in VLSI. There is also something more interesting that we have done with certain universities, of course, that required more context. That is, a certain faculty sponsored by the institute can be stationed with us for about 2 months. And we have about 10 such cases in last 5 years. I wanted to bring to your attention. We have been involved in delivering and creating some IoT/AI courses with certain university when they requested like that. So we can discuss this. And we also had this VLSI course building and co-delivering at PG level with certain other things. I showed you one slide of the IESA before. I can also mention to you that for IESA, I happen to be the IESA Executive Council member also, where I am leading this talent and skill core initiative group for them also. So somehow our paths are, let's say, intersecting at many places. I just want to say that with certain university, when we delivered these, let's say, these programs, it's possible that we can deliver, let's say, online speeches, our employees based on their real experience. This is another lecture series for a university who wanted to educate their entire university, and this is top tier University of India, who wanted their entire faculty plus students, let's say, focused together on the IoT, AI, and what is happening at the edge. And by the way, the tools that I'm showing you, these were the tools around which everything was done. As a bonus, and to end my presentation, because the content is about VLSI. So when you are in VLSI, you are doing research, etc. Of course, there are different aspects. We have TSMC, we have SCL, we have everything. But should your interest be in MEMS, we are, by the way, #1 MEMS company in the world in terms of the consumer MEMS. Should you have this interest, particularly in the piezoelectric MEMS, we are available to talk to you, to give you access to our fabs. And our fabs are based, one in Singapore, another in Politecnico di Milano, and we can, let's say, talk about that. So this is one of another research offering to the universities where you can start talking to us. The only condition is that it has to be piezoelectric MEMS. It's not everything in VLSI, one specific area. Then we can talk of, let's say, how you can access our fab, and needless to say that this is very, very low cost, so to speak, if we agree for it. With that, I'm open to Q&A, and my mail ID is here besides Sridhar. So Sridhar is the one who is to be contacted for boards. If there is anything else what I spoke in the end, for example, some faculty or development program at ST, or maybe some remote webinar, something to augment your own course, you can contact me.
Thank you so much, Manojji, and thank you for such a passionate this thing. He is one expert who has even brought in various tools and various things to show to everyone that what is it all about. And we will reach out to you because we really want that all our college should be empowered. So for having those faculties on campus, we Chairman sir also discussed that with me, that we will be selecting the institutions from different parts, and then we will be coming to you with a proposal. If you can host some of our faculty members for absolute hands-on experience. Thank you for your presentation. Any questions, please? Yeah.
Myself, Dr. Ganesh from CVR College, Hyderabad. So in the curriculum co-structure, this is for sir also, like it is mentioned lecture and practical for every subject. If we observe, starting from semester 1, in almost all the semesters, we have around 4 to 6 labs along with the theory. And where it is mentioned like 2 lectures for theory and 2 for practical. And these 2 are running in parallel. So before theory, the student may have a lab, or during the theory, the student may have the lab. And these are some of the advanced topics to be covered, and which are the new for the students. So how we will mix up these 2 at the as a faculty level. So for that, is there anything available? Yeah. So is there anything available from the ST Micro or from Cadence or Synopsys showing that related to this lab, these are the particular tools available, and these are the contact numbers to be approached? And
I will share with you, but yes, to your part, about lectures and tutorials and then practicals, I think Alex would clarify.
Yeah, so one of the core thing that we were looking at is how do we bring in experiential learning into the program. So the idea of the practical is not just to getting the student to a lab, but even to convert your teaching session to a lab-based teaching sessions. So that is it's the definition of that credit that you bring in, and that can be delivered in many different ways. So what we could do is within those each program, we can add like the resources. So that way put bit more guidelines.
We have a limit saying that these many theory hours, these are the lab hours.
Yeah, yeah.
So if we have 2 hours for 16 weeks, we'll get around 32 hours.
Right.
And if we show it in lab, so can we change the hours and
No, it's a guidance. Like the idea there is like, for example, the idea of lecture there is more like a contact hours, how much you spend. Now, whether you spend that contact hour in a lecture room or whether in a lab, is a completely different thing, right? So the same thing, the lab component, the way you need to think about the lab component is not the students always sitting in the lab. Even the garden can be a lab, right? So it's it's the way you engage. So you give a task, like it may be a project. The project can't be always that, like, you monitor within the lab. It could be extended. It could be outside the teaching hours, and so on and so forth. So it's basically accounting for the work that the students actually do in practice is reflected as a credit there.
no, sir, no. So here it is mentioned as one internship or foundry visit for the post-structure. So is there any support from ST Micro for the students? Because we will be having around 60 students where they have to go for internship or foundry visit. All students should go to the VLSI related event, unlike other specializations. So what the companies will give support, or AICTE will help us in reaching out these internships or any facility to the students, because it is very difficult for a.
We will speak to all our industry partners and we'll try to see. But Alex, can you inform various labs that are available so that institutions can approach those labs since you are in this field? So in different parts of the country, whatever labs you're aware of, you can just announce that these are some of the labs where this experience can be.
So the idea is we'll collect like all those, like for example, clean rooms, like, you know, unless and until like there is an experience visiting those clean rooms. So that region wise, there are like labs where you could just go visit, get the students given. So all those things will add into the curriculum so that, like, you know, you don't have to run around, find where these things are. So putting the contacts and all those things. Same thing with the tools as well. Like, you know, there is a variety of tool options that are there. In some of the courses, we put like a broadly resources. So within that head, like we'll add all those things. So that way, finally, like when the curriculum is seen, that, you know, all those supporting ecosystem that connect that is required, we can add on.
Now I would request Shri Sitharam Singh from Synopsys to kindly address the gathering, and if you have a slideshow, you can also put on the slideshow. Thank you.
I didn't understand this part. Yeah, that's what. Yeah, already there.
We didn't want to confuse the lab documents.
So what we could do is for each courses, we can just list it. Where is the facility? Actually, traveling to Singapore is
Institute. It's in our own
okay.
so still live in there.
Hello everyone, thank you much for the introduction.
Is it possible
I
to
take care
visit there?
of Synopsys academic program.
Actually, traveling to
What we do. So before we get into that, we are all talking about VLSI, so I thought I just take that our technology is used for all kind of chip design. So we are all in that chip design space. We are an EDA company. So be it from networking to mobile, high means high power computing, automotive, whatever you can name it, we have a solution there, right? And almost like 90% and above tech do this in some or the other way. Some of this technology. So I just keep it a bit generic upfront, few slides, and then I'll get into the resources part. So, okay. So as we are advancing, we are seeing people moving up from PC to internet to mobile to now IoT, and going forward it is artificial intelligence and whatnot, right? So we are all there, and if you see the things with Moore's law, we are seeing that number of transistors are going up, and because of this whole idea, Synopsys came into a being, right? So who are we? We have, sorry, the animations, okay. So we are a leader in chip design software company. We have a good number of reusable IP portfolios. We are number 12 globally in terms of revenue. We are having a presence in close to 125 locations. We are a $6 billion company. As Professor Alex mentioned, that we are somewhere around 20,000 employees. In India, we are close to 6,000 and we are expanding. Right. So if I have to say what is our vision, it is more our technology, your innovation. That is our tagline, and that is what our vision is. So it is not just that we do something which is at a very smaller scale. It is more for the customers. We are customer centric, and that is what drives our purpose or mission or what is our value proposition, right? So now that AI is there, we are all moving into a pervasive intelligence era, and which is something which is very important for Synopsys. And being an EDA company, we are also moving from silicon to system design. And like there is a system design course which is already added into this platform. So we are all a part of this, right? So
it is not just that we are working with some limited set of companies. We work with system companies, right? We work with silicon chip companies. We work with silicon manufacturers, right? So that is a smaller picture, but I have to say what is our entire portfolio, right? So we make things possible for these many set of organizations. Many of them are here, right? Right from productivity to the system companies to other EDA things, we are all partnering there. So this is just a very high level thing. Apart from that, Purva did mention to have what is our corporate responsibility. So I just took one corporate responsibility slide. We are all working with some environmental cost, the social cost, governance. Same way we have started doing some activity in this region as well, especially on the social front and on the environment front. So what is this program all about, and why are we here? And how can SARA, which is Synopsys Academic Research Alliance, can help anyone who is venturing out into BTech VLSI, right? So the whole idea is to bridge the gap. From morning, we have been listening that there is a gap, there is a disconnect between industry and academia and vice versa. So the whole idea is to bridge that gap. How do we bridge that? We have four major pillars, if I have to put. One is, because we are an EDA company, software is something which is required. So we have a university software program. Apart from that, we do education partnerships. We have started venturing into research partnerships in India, especially at the academic front. And last one is on the ambassador program. Ma'am, can you just zoom in a little bit? Negative. Zoom out. Yeah, or you, yeah, thank you, ma'am. So in university software program, we do provide our tools to academic partners at a discounted pricing from what we give to multinationals. But it is not just that the tools, what it comes with. I'll showcase and what we have offered under this program. I'll also touch base on that, right? So apart from that, we are also doing where we do a lot of activities like faculty development program. We are now running every month student workshop on different tracks. It is free of cost. We take only 100 students, and we have set a criteria there, and based on that we work, right? We are also doing some hackathons. We are doing some design contests with different partners. As I mentioned that we are venturing into research partnership in India. Our entire academic R&D was concentrated in Europe and North America, but now we have started venturing out into the Southeast Asia region as well. And for our employees, we always say that, hey, always reach out to your alma mater, be a good ambassador. So we have a dedicated program for that. And all these things are being taken care of. So when we talk about the software program, we have close to 200 plus products in our portfolio. But just by giving product is not like solving the purpose what we are seeing. So apart from that, we have volunteered to give close to 130 plus subjects, which you will get as a part of this BTech VLSI framework. We have given a link that how it can be accessed. I will be talking about that. So there are like 130 plus courses. There are resources which is available for academia, be it the generic libraries, be it the IPDKs. IPDKs are supported up to 14 nanometer. Then there are some reference compilers and reference methodology things which is available as a part of our offering in this. Along with that, what ma'am has just mentioned that even if things are there, you need to provide a good quality support. And we have set a system in place that our turnaround time, especially with academia, has now changed from months to 3 days. And we have put people there, and if there is nothing happening within 3 days, then I will have to take it up. So that is how we have done this changes. So how do we get access to the software and these content? So whenever you get our software, there is something called as SolveNet Plus. So any academic institution can create 2 user name and logins, right? And those will be the primary account holders. Generally, if what we do is we provide it with the HOD or some faculty who is running that lab, because they are the one who needs to do all the installation to get all the things. We are not enabling any students to directly download anything, because there may be a chance that they may end up with some broken link somewhere and they are not able to rectify it, right? And then along with that, there is something called as Synopsys Learning Center. And in that one platform, single window platform, you have all the things available. There are self-paced courses, there are instructor-led course. For academia, we are offering this for free. All the course content, I will be showing that as well. And what all does it include? So how do we access this curriculum? So if you want to do it, there are 2 different ways. Very simple, just go and Google search Synopsys Sara. The page which will show up, just click on the first link, University Software Program, Sara, Synopsys, right? And when you open that, in the 3rd tab, there will be something called as curriculum. You can see it down, right? So there are educator, this and that, and there is a separate thing called as curriculum. We have bifurcated these 134 subjects into 4 categories: IC design, EDA, advanced courses, and general courses. And all these courses can be easily downloaded from there, right? And like I mentioned about the Synopsys Learning Center, that will be the 1 point thing where you can get all these content. Like this. Yeah. So how do we enable universities, right? So this is how you get all these things. So you have a tab on the right side where you have all these IPDKs, library, memory compilers available. You can just go there, download things, right? And there are reference methodologies as well, which can be easily downloaded. Another way to access this, not just the content or the PDKs, but on the training side as well, you can just log into training.synopsys.com. Use your same login credentials, which we have discussed. So the page which is on the bottom, that will show up, and on the top left side, there are 3 hamburger symbols. Just go there. So something on the center, you will see there is a learning center. If someone who is a part of C2S here, you will see the C2S content there. Then for any academic institution, there is a university thing. So just go to university program. These courses are available there. So you can just scroll and make use of that. So how it looks like. So if I'm just taking an example, I've just taken analog integrated circuit as an example. So if you just click on that, you will have about the course, what all topics are covered, right? There are contents. We are providing PPTs which you can reuse, modify, use as it is. There are lab files, which are test cases and examples. There are lectures. There are course projects also for that particular course. So if anyone is interested, I need to do some some project related to analog IC, you can just take it out, give it to the students. And the tool which is required for that particular course is also mentioned there. So all the lab manual will have all the codes and everything, so you can easily plug and play with that, right? On the right side, you can see the other set of course. The same process is followed there. And in additional information, we have just given which tool will be required. So you can just download that particular tool for your lab. Apart from that, if you want to do something beyond your university thing, especially for students, there are courses again accessible. So suppose I want to become an analog designer, I'm just sticking to same portfolio, right? So there are courses and there are some legends which is seen there. So that these courses are self-paced. Some are video lectured, some are presentation. Apart from that, some courses which are bit advanced, that these are instructor led. So this is also available as a part of our offering. Someone who says, okay, I understand the flow and all those things. This is something for a job oriented thing, but now it is more on a product. If I want to learn in detail a design compiler, right? So there are courses for that. So I can bifurcate role based or a product based and then do as per my convenience, right? There is a course plan which is available. This is also what we have shared. And this is just one example. I'm taking the first block, the IC design specialization, right? Again, it is the first year, second year, and these course contents are not just limited to 45 or 48 hours. It carries all the fundamentals to advanced things. So some courses you may get, including labs, like 160 hours, 180 hours content. So as a faculty or as an institution, you can take a call which one you want to use, which lab experiment you want to target. It is just for you to take a reference. And on the contact details side, before I move to the last part, we have two aliases, and these are constantly monitored by me and one of my colleagues, right? For anyone asking for licenses or course content, or who is already having a license and they have some difficulty related to tool access, you can write to synopsis-india@synopsis.com. Anyone or any organization looking for workshops, FTB or training requests apart from what we are doing on a monthly basis, you can write to sara_training@synopsis.com. So these are the two mail IDs which I monitor. And with first one, I also give support access using the same mail ID. So anyone who wants any kind of support that I need to have this lab flow set up, or I'm unable to do it after following the content what is available, you can just shoot us an email, we will help you out. And like from morning we have been discussing, so I'll just finish my presentation that it is not just the industry or academia who can do things in this space. It takes an entire village to build a chip. And there are companies like on the very bottom of the pyramid, if it is, I have to name them, they're all IP providers. Next step are the EDA players. Then there are companies who do provide specialty chemicals, so that tomorrow when someone is venturing out into some manufacturing course and all those things, so you know where to get your chemicals from. Then there are companies who provide equipment. There are IDMs. There are, at the end, there are fabs, right? So we hope to see some of our Indian names right at the top of the pyramid very soon. Thank you. And if there is any questions, feel free to ask.
Thank you, Sankalpji. Thank you so much. And in all my interactions with the faculty members who are at the institutions that are actually initiating VLSI, there is a lot of anxiety. They feel, where will we get the tools? Where are the labs? Where do we get the content? So each one of you is sitting here, and all the 250, 300 plus people who have joined us, please understand that things are available. The course contents are available. The trainings are available. The tools are available. It's just that you need to explore. And that was the reason that we invited all our industry partners, and my heartfelt gratitude to Mr. Purva also for, collaborating for this wonderful journey, which we are all undertaking together. And if you really want any more help, please reach out to me, so that as a barrier, as a bridge between the industry and academia on behalf of AICTE, I can connect you to the right partner. I can connect you to the right one, and also explore yourself. Please, all of them have provided how to approach various companies, what are their email IDs, what are different verticals that are available, what are the MOOCs courses that are available, different, training programs that are available with them. So please make use of all these facilities, all these resources that are at your disposal, and mostly pro bono basis. So I request you, please explore, and if you still have a problem, please write to me, and I shall come back to you either with a solution, or I shall connect you to the right person who can provide you the solution. And now over to Prabha Bhattaramji, who is from Cadence Design Systems, to give the presentation. Thank you, ma'am.
Namaste. Hello, everyone. Am I audible? Online folks. Yes. Slides are visible.
Yes.
Good afternoon, and I'm Prabha Bhattaram again, and I'm from the Global Technical Education team at Cadence Design Systems. So this is what I want to cover in this very short, super short presentation, and we are all available even after the session. So please approach, and we cannot kind of cover everything that we have to collaborate with each of the universities. So please reach out. So I'll just quickly touch upon Cadence as an EDA entity and bridge the skill gap Cadence initiatives, some of the initiatives which are already successfully ongoing, and spend more time on Cadence courses in AICTE and support for these courses and the university faculty as well as the students here, and touch upon the Cadence University programs again, and what is the next steps that we would like to do with the AICTE. So Cadence is a known strong player in EDA, and as Alex was initially showing, we have close to 12,000 now, Alex, globally. So yeah, growing and very active, developing and deploying computational software. So just pay attention to these different streams of product lines that we have from Cadence. There is a reason that I'm showing this. I'll just connect back to this when I talk about the courses that we offered for the AICTE. So we do have the IP, the verification IP and the design IP, and the implementation stream, which covers the front end as well as the back end synthesis and digital sign off. The system verification, where hardware system verification, advanced verification solutions, as well as the acceleration, and the custom IC and the PCB, the board layout stream, and the more recent one, computational fluid dynamics, CFD, and on the thermal electrothermal analysis side. So these are very strong product lines that Cadence as an EDA carries. So we talk, everybody understands what is skill gap, and that is why we are all here in this room. So not going to define that. So what is Cadence? What is Cadence doing in this direction? So we have been having Cadence University relations for a long time. There is a long list of universities in this program, and we chalked out skill gap initiatives, which is as recent as the past 2-3 years. I would like to talk to each of you, both online and those who are present here, to reach out to me, and I can present some of the things that we have been successfully doing, not only with the universities, but also we are working very closely with finishing schools. So I will talk about that. And we have a very successful internship program. So jumping right into what is very relevant to all of us today, right? So the Cadence AICTE curriculum, and what is the different streams that we decided to offer in the industry elective section. So if you remember the 5 product lines that I showcased in the second slide. So we divided into different streams in those 5 streams and decided to pull in the basic courses, which are conceptual, plus adding the tools part of it with the labs and the technical support that is required. And then we have about 125 courses, which we prescribed as part of the AICTE curriculum. And these are for different student interests. So if you look at the streams, right, there is front end and the back end on the digital side. And if you go on the analog side, there is a front end and the back end. And the physical design and verification and the board layout at the end of the stream. So not all the students want to take everything. I know Professor Alex was showing that we do, introduce them to different aspects of it. But when one takes up the career, right? So we kind of go into that particular interest and go down that vertical. So keeping that in mind, we have introduced these 5 streams: front-end design verification, hardware acceleration, and system verification. So system verification is something not very widely prescribed in the curriculum. So that is something we have added on into the courses. And digital design and sign off, which is the implementation backend, synthesis and timing sign off and such. And we have very good courses on the analog mixed signal and RF design, custom IC and physical design and verification, and the board layout, right, at the end. And we have included, I said a basic course, but we have a couple of AI and ML courses that have been included to introduce the students to this whole new world of AI and ML. Most of the tools from the EDA companies, we have incorporated these flow into the tools already. So it's very critical for the students to understand the underlying concepts and what is this AI and ML. So we have introduced that as part of the curriculum. And all these courses can be taught live, and they have online versions. So they have audio and supported by animations to guide the user through it. And they have been fortified by very good labs and the learning concept. So most of the courses, even though we are a tool company, we try to explain the conceptual part of it and then dive into the tool. So we have tried to do that over many years, and you can see that evident in these courses. So the Cadence online training, so it is available as online training also. We have lectures with audios, with labs. And the most distinctive feature of all these features is we have a certification exam for each of these courses. And once the faculty or the student, they take this, they can earn a badge. And that carries a lot of visibility and exposure for the student, especially for them to go on display in their LinkedIn profile and their resume and such. And even though it is not in the AICTE curriculum, we have new courses on the CFD and the processor IPs, which we we can offer that if there is a demand on demand, and we can facilitate the registration into that. Again, just bringing your attention to the distinctive advantage that the students have by taking these course badge exams. So these exams can be attempted for after completing the course, allowing the students to earn a digital badge in a specific technology area. So these are all the screenshots of different courses that we have. All of our courses are badge exams, but I've just displayed a few here. So again, earning these digital badges enhances the chances of entering the EDA industry by showcasing their expertise. So ma'am, one of you had a question, right? So what is the employability, right? So, and Professor Alex was explaining that industry will look for certain skill set, right? So there is a conceptual theory and their GPA on one side. On the other side, we have very focused hiring, at least from the Cadence side. So what do we look for? We look for if they have taken these courses, right? If they have earned a badge, then there is a sure shortlisting that can happen for the students. So just wanted to highlight that. And what is the next steps that we would like to do, Cadence would like to do with AICTE and the associated universities? Focused discussion by our subject matter experts with the faculty on specific technology streams and courses. So come back to us, write to us. I have provided the contact info here. It's just me, prabha@cadence.com. So I work with different teams within Cadence, and I'll be the point of contact, the single point of contact. So there is no ambiguity in reaching out. So we have provision of train the trainer support for the faculty. So we have done this with several other universities. It's a very tried method, and we have been successfully doing that with not only Indian universities, but even outside India also. and interaction of students with the subject matter experts. So we are more than happy if you invite us, so we will come and talk to the students, enhance their interest on the VLSI domain. So we do have as part of the university program, customized license bundles at a very discounted rate, which is already part of the Cadence University program. So that will apply to whoever takes these courses also and the universities. So I will not go into the details of what are the license bundles and such, but please reach out to me because each university has a specific need. So based on that, we can kind of help you out with how we can help you. Just trying to quickly go over the Cadence University program and the advantages that it offers. So we have a long list of institutions we have been associated with, 350 plus. And I would like to just highlight on the last but one bullet here, not only in India, but outside of India also. And some of the university members who are present here, they're already aware of this Chips to Startup C2S program with Cadence, about 150 academic institutes. So I would like to talk more about that if you're interested after this presentation. So just quickly highlighting the spectrum of initiatives that we have from the Cadence University program. So we have tool demos, we can organize that. New hire training program that happens as part of the internship. Technology workshops, we can kind of get together with the universities and arrange for that. And several training programs we have both for faculties as well as focused areas for students. And we regularly conduct university webinars. And that is part of the way of reaching out on different technical topics. And we have university engagement just like through our channel partners and also directly with the universities in terms of license and technical support and such. Yeah, one of the things I would like to bring your attention to is the support.cadence.com portal, which is our support portal, which has all the information that one needs to know on our courses and all the tools, the product manuals, and even short videos on how to use the tool. So they are very popularly known as the training bikes. And this is where even the digital badge exams are also present. So these are all the different things that one can achieve once they log on to the Cadence support system, support.cadence.com. We have online courses. We have short task-based training buys, which are very popular with customers as well as university students. We have the badge exams, and we have lots and lots and lots of troubleshooting information, right? And we have product manuals and the racks for each of the technology that we release, right? And one more thing, so we do keep updating these courses. It's not like we prescribe these and they are stale for 2-3 years. So every year, at least twice, when the software is released, a new version, so at least twice we do update these courses, and these will be made available on our portal. Yeah, so that's all I had today. And please reach out to me if you have any questions. And the email ID is prabha@cadence. Simple as that. Reach out to me, and so if you want to have any questions, thank you.
Thank you so much, ma'am. Madaliji, please check the chat for questions. Madam, please put on your mic.
The badge exams that you mentioned. Yeah. So are they paid ones or no? How do the students know? So it is not a paid one. It's available on support.cadence.com. But the prerequisite is the student has to
Go to chat.
then take the ribbon. Otherwise, it won't get activated. So that's you think that one login, how? That is a question. good question.
I think individual students will have to log in because most of the places, it is actually the individual student who has to log in because that certification is also individual.
Yeah. The bad thing.
So, generally I have seen that, most of the industry partners where we partner with, if after taking a particular course, if the student want a certificate, then generally it is an individual learning because one student after consuming the content is actually validating it, assessing it and certifying. So most likely it should be the same for cadence. So you may check that. I was seeing that you wanted to say something. Kindly, introduce yourself. I'll come to you. You may. आप खड़े हो जाएंगे एक बारी हाँ सब देख भी लेंगे
So can you, madam, some insight onto that to start off? This is coming in a big way. We are listed. The government of India.
That's a part of MIT. Yes, so you'll have to connect with them.
No, actually, what Prabhaji said that Cadence has a specialized program that is called Chip to Startup. So
Yes.
they are talking about their specific program. No, it's a MIT program, but Prabhaji said no about Cadence.
We are all part of it.
It's a MIT program. I know, but I thought probably Cadence has a separate.
How they are going to support that?
We are part of
So you'll have to connect with MIT.
So I can briefly explain part of that. So as part of the program, you have like the entire set of tools, even for those participating institutions. And then last for 1 year, like there have been a lot of training programs actually arranged for each of those tools. So you get basically access to the tools and also all the training that is going on, which can be given to the
Because the customers have given to the IITs. So we missed the first assignment, which has come back to.
So there's again another call for
There's
this
another
year.
call I feel.
This is what sir is talking about is the 130 institutes that they gave last year. Got this CTS fund from MIT. This year again there is a call for. You can please go to the MIT website. You can check for the call for. Apply for.
There is a separate CTS website for this, so you can actually.
Someone else had.
Yeah, you had a question, please. Yeah.
And we are from Manipal Institute of Technology. We are using Cadence tool from more than 15 years now. And yeah, this is actually the question we were also facing, but we found the solution for that. So the solution actually every student need to register.
That's what I said. That's what I said.
Good thing is actually again we thought that since the student if they passed out, suppose if they work in the industry, they may misuse or our tool since it is academic license. So what should be the possible solution? And we connect with the Cadence. They told that after 6 months it will be disappear or again it need to be re-registered. So every student can get access of this rapid access kit and they can register for the course and get the badge.
Thank you.
I suggest other thing also, an academic institution, once the student kind of passing out can inform them that, this is the batch of a student who were registered with you are passing out in 2024. So Cadence can disable that particular registration, not to misutilize the tool because these are academic licenses and are a very discounted rate. So both the parties should make sure that nothing is misutilized.
You can give the access to the Spark.
Get disabled once they graduate.
Yeah.
So that is what we are following at Synopsys. We only allow university credentials, right? Something at the rate, some university, right? And we make sure that if the student is signing up first year, is disabled anyhow after 4 years, and all the BA players they have the same 6-month thing, right? So it is nothing new for everyone is doing separately. Everyone follows the same thing. See, onboarding is not a problem, but offloading students once they graduate is a problem. So because many institution, the ID still is valid once you graduate, right? So that is something what we work.
You wanted to say something, ma'am?
said, the institution license, what is given for the faculty or HOD, that still remains. The student who registers separately, only that get disables.
Right.
And that license anyway is there with the HOD or the faculty, so that can be used, reused.
Right. Right. Anyone else? Yeah, please, ma'am.
Madam, all this certification branches, how about we come into
In fact, before they reply, I want to say it's an excellent question. Actually, now we have National Credit Framework, NCR. What it says is that every content that is actually, studied should be creditized so that, students not only get certificate, they also get additional credit for it. So suppose, and what is the requirement for assigning credits? Number one, the outcome must be specifically known in the beginning. So if I read these, this much of content, what would I know? So that is an outcome. And after the outcome, the number of theory or practical hours should be well defined. So that, these are the number and then the assessment process should be well defined. So only three requirements: outcome predefined, number of theory and practical hours are predefined, and assessment process, all the three are predefined. And once you have it, you must convert. I request all my industry partners here, you must convert them into micro credits. So suppose something has done something from synopsis, you say that, okay, I have 160 credit as done B10, but I have also gained 7 credits from synopsis. I have also taken 3 credits from cadence and maybe 2 credits from ST microelectronics. Then what happens when somebody looks at the resume, that candidate has actually accrued or earned 167 credits, and that's always an added advantage. So this is my request to all of you, that you have not creditized it. If you need any help, please reach out to us, reach out to AICTE, but please assign credit to all learnings. Thank you. Now you can answer.
One thing that you could do is in the current framework is to look at how do you take those into the program, and there could be multiple ways. For example, if you are seeing it as a blended learning, then you might be using those online content as part of the course that you have designed. Okay? So that way you could define how that credits are going to go. Now there is other case where the credit is already defined by the industry. Then you might as well, through your academic councils and others, look at whether those credits are matching with the credit definition that you have, okay? And then adopt that and transfer that credit into your system. There is nothing like a blanket approach of taking, like, so each industry may be saying this is 1 credit, other maybe 2 credit, and so on and so forth. Yeah, so this is something you have to bring in as part of your teaching and learning process to see what is meaningful for you to deliver. You could completely take it as an online content, or you can use it as a mix of online as well as taught content, or it can be a supplementary material to your taught content, and so on and so forth.
Actually, Alex, it can work in 3 ways, Professor Alex. Actually, one is that, they get 160 credit as you have assigned from your this thing. And whatever they do from industry, so their relativity may work. Suppose ST assigns 2 credits, Cadence assigns 3 credits, they assign 4 credits. There it is over and above the credits, which are mandatory credits for a PTEC program. This is one. Secondly, they make it part of SWAYAM or SWAYAM Plus. There the credits are, it is evaluated, and after that is put in. So for example, if suppose any of the industry makes a 4 credit program, then, we kind of put it to an expert committee, and that says, okay, this can substitute this specific credit which is given in the curriculum. Then it becomes part of 160 credits. So it can either be supplementary, complementary, or it can be all integrated, inclusive of it. But if we want to make it integrated and inclusive, then all the partners present here, industry partners, the relativity of their content cannot be variable. It means if you give 3 credit to something, you should also give 3 credit to that, you should also give 3 credit to that, and you should also give 3 credit to that. So uniformity, standardization of credits will be needed should you want it to be inclusive of the mandatory credit required for a BTech degree.
So the thing is, there is already the guidelines on the credits, which is nationally adopted. So
Yeah, National Credit Framework.
yeah, so that just needs to be followed.
Anybody else? I think there was a lady. Yeah, ma'am.
I would like to add, she said, we have another program called Tech Domain Certification. So what we do is we bunch up the courses which are related together. So for example, for a logic design engineer, as a student, what are the courses that need to be taken? So if there was 4 or 5 described courses in the tech domain, then they pass all the badge exams, they get a combined badge for that. So that carries a lot of weight, and we are working very successfully tech domain certification. So that applies even for faculty as well as individuals. And
You wanted to say something? Okay, ma'am, please you. You are from Punjab Engineering College. Okay. You can just come here and use one of the mics, please. Yeah, and there is a chair also.
Huh?
We had the C2S of the last year. But in C2S scheme, we are unable to make systems. Whereas tool we bought, we are using those lessons. But under C2S scheme, we are unable to use. Who do I see? Not with the cadence, because we are cadence.
Any members too.
under one consumption. That is the outcome.
So thank you so very much. It is my time for my closing remarks and to convey my heartfelt gratitude. Many of you may not be aware that the team, though chairman very, very briefly mentioned about them, but once again, I really want to take everyone's name and I want to express my heartfelt gratitude. None of them have been paid a single penny. And they all came together and worked tirelessly. And I'm repeating, emphasizing the word tirelessly for making this curriculum a huge success. So Professor Alex James from Digital University Kerala, who is physically with us, Alan Escoli from Tennessee University, Dresden, Professor Garrett S. Rose from University of Tennessee, United States, Bhaskar Chaube, Professor from Scheigen University, Germany, Professor Harish Bhaskaran, Oxford University, UK, Professor Rajesh Jele, IIT Mumbai, Professor Ronald Tetzlaff from TU Dresden, Professor S. Shrilal from ISRO, Scientist G, Professor Sung Mo Kang from University of California, Santa Cruz, United States, Professor Shahar Kavinsky from Israel Institute of Technology, Israel, Professor Vishal Saxena, University of Delaware, United States, Ashwini Agarwalji from Applied Materials, Apurva Verma from ARM India, Monideep Datta from ARM India, Sankalp Singh from Synopsys, Professor Satya Gupta. I mean, he is unstoppable, but he really, really contributed quite a lot from VLSI Society of India, Ashish Kumar from ST Microelectronics, Prabha ma'am from Cadence Design Systems, and so on and so forth. And above all the stakeholders, when we circulated this for about almost 2 months on our website for stakeholders consultation, such valuable suggestions have been received by us. So thank you to this committee, which really worked tirelessly. And I want to tell you, all the experts have really almost covered everything, that curriculum is the backbone, or curriculum is the foundation of any teaching learning transaction that takes place. And we at AICTE, Policy and Academic Planning Bureau, have been very, very conscious of the fact. And that is the reason that each curriculum, and 17 curriculum in last 1 year we have revised, each and every curriculum, the experts have been distinguished experts in their domain. We have had at least minimum 40% people from the industry, and every curriculum has been drafted after a meticulous consultative process with all the involved stakeholders. We have made sure that it is student centric. There is flexibility available to the students to take minor and major, to take core electives and open electives, to make sure that it is absolutely comprehensive, industry aligned, and preparing students for their futuristic job roles. I request all the people who are present here, please visit AICTE website and adopt the model curricula of all different domains that is available, because the kind of work that goes on, it takes 6 to 8 months to finalize one particular curriculum, and then only it, after a consultative process of each and every stakeholder, it is uploaded on our website. And same is true for VLSI. It has been one of the most appreciated curriculum, and tell you 9 IITs have adopted this curriculum. In AICTE, it has happened for the first time that, we have received such huge appreciation. On its own side, AICTE has been doing a lot. I have informed a lot of things to you. We have an integrated circuit curriculum for diploma level program. We have written to all IITs, IIITs, NITs that their PG and research program should also be aligned to the semicon mission of the Government of India. We have had faculty development programs with Semiconductor Lab Mohali, and also exclusively faculty development programs in VLSI domain. Our chairman led a delegation to Taiwan, and then Taiwan's Deputy Minister of Education also came to India, and large number of MOU have been signed. One university that has been particularly doing quite well and has really gone ahead than many others is Shastra University. And they are also funding 6 months internship of the students in Taiwan. And I think they have also tied up with Tata's. They're part of the funding of the student is also coming from Tata's. IIT Mumbai has done a wonderful work. IIT Guwahati is catching up. And if any one of you, I am available 24/7. You all have my email ID. Please write to me. If there is any problem anytime, either I am able to solve this or I am able to connect it to the right partner in the industry. And let us make India a chip ready nation. We have done wonderfully well in chip design. It is time for us to do wonderfully well in chip manufacturing. It is a very, very complex and capital intensive field. So please, drop down your guards, drop down your silos, come together. If you have resources, allow others to use it. Finally, it is for nation building. And I'm extremely thankful to my worthy colleague. He is Dr. Dash. He is our senior most advisor, advisor one, who has joined us a few months back for being here. And he has been working very, very closely with the Honorable Minister at the Ministry of Education. So he will also apprise the minister that, AICTE is really doing quite a lot. My worthy colleague, Dr. Dinesh Singh and Vamsi ji, who have been instrumental in making this a great success. And thank you so much. My heartfelt gratitude to each one of you. Please convey it to Vivek Sharma ji. Please convey it to Guru Ganeshan ji. And of course to Jaswinder Ahuja. Unfortunately, I have not met.
Maybe you should take the name.
So, all right, Sashi ji. So I have known all your leaders and I know how committed they are to it. So let us all come together and make chip 2 design a big success and chip to, the final product, a big success. Thank you so much. Heartfelt gratitude to each one of you. Thank you so much. Jai Hind. Thank you. So we all will assemble outside for a group photograph. Please come.
Lunch be announced.
And then lunch.